Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay guys, welcome to chapter 4, synchronous machine. So for part 1, we will be going to discuss on the synchronous generator. Then we go to synchronous motor. Because most of the machine in the market which are applying the synchronous kind of machine, they're focusing on the synchronous generator. Okay, we're going to use this slide which is created previously by Dr. Hamizah Faith Arifin last year. So we go through these notes. You can jot down any kind of notes or updates from our discussion into the notes, and we shall discuss on the synchronous generator, and then we go to the synchronous motor. We're going to use the same textbook of Chapman. Most of the exercise will come from the books. Okay, as a reminder, your session will be tested, and your understanding, your comprehension on this subject will be tested accordingly. Because in your test 1, you will be test on the DC machine and also induction up to 3 phase. And you have your test 2 coming soon on this 14 I think. Will be tested also on the DC machine and induction. Most probably will be on the single phase. Okay, and then your test 3 will be solely on the synchronous machine. Okay, please take note on that. Okay, then this is your slide. Okay, sorry. Okay, we shall discuss in terms of the sequence here. So the content will be the constructional of the machine, generator. Okay, then the basic parameter of your machine, then the parallel operation of your generator. Most of the generator will be used on the machine, on the system which is going to be used as our generation or electrical generation site. Usually in the hydro power, wind turbine, and all the machines that going to generate AC source to the grid, most of them will apply this AC synchronous machine or synchronous generator. And then we go to the principal operation of the generator. Okay, in terms of your mechanical construction of your generator or synchronous generator, we shall have 2 main parts. And this AC generator usually, or most of it, the construction almost the same, like your separately excited DC generator, which is if your DC generator will be connected to positive and negative. But for AC synchronous, this one will be connected to AC. But right, if your generator, so it will produce current, and this is your output current, AC output current. And then this is your rotor here, same. And this is the rotating part, so-called rotor. And so this is your rotating part. This is your stator. And stator is here, rotor is here. It's rotate. For generator, this will be rotated by external source. Let's say you put your generator on the dam. So this is your turbine, and the turbine that connected to the dam. So when the water falls to the turbine, it will rotate your shaft. And your shaft here, for synchronous machine, we shall have a pole which connected to the windings. And we have poles here. The more the poles, the slower the rotation needed to generate AC source. And so you have poles here. You will have magnetic fields which connected to the poles, You have positive, negative source which produce electromagnetic fields. So when the shaft rotates, the fields will rotate. And so when the fields rotate, it will generate voltage difference between your poles and will generate current to the terminal. So this is your terminal and to the grid lah. Okay, this is rotor. Rotor referring to the rotating part. Stator referring to your your stationary part here. And armature. In terms of electrical terms, armature is the power producing component. So this is considered as armature. And this part is armature. Then the field, magnetic field component of electrical machine. So this is your field. Field is here, armature is your external here. Okay, the magnetic field can be provided either electromagnet or permanent magnet. So this part, either we put a permanent magnet or we put a source of DC here. And the DC here we put to the rotating part. So we can provide the electromagnets to the poles. Okay, synchronous generator or alternator, so-called alternator of synchronous generator. So the rotor magnetic field here, in the middle parts here, is produced by permanent magnet or applying DC to the rotor winding that I discussed before. So the tables listed the difference between DC machine and AC machine. So DC machine means that the machine is that connected to DC source, compared to the AC machine is connected to the alternating current source. So the AC machine for sure, in terms of supply, they works on AC, and in terms of DC, it works on DC, and mainly from batteries, which we use in EV cars and electric vehicles car, scooters and electric vehicle scooters, and all your DC supplying sources system. And the supply system can be single phase or three phase. In terms of AC machine, we have three phase system. So we have either three phase induction motor or single phase induction motor. But for DC, we don't have any kind of phase, so only have one phase. In terms of starting, and the AC machine, we need starting mechanism for single phase. But for three phase, we have already the rotating magnetic fields, so we don't need any kind of starting method like we are experimenting right now. The starter, the capacitor start, capacitor run to the machine or the AC induction motor. So for DC machine, it will be self-starting. In terms of stator and rotor characteristic, the field windings on the rotor that produce magnetic fields or the rotor winding. So the field winding, we have field windings on the rotor which produce the magnetic fields. In terms of DC machine, the field winding is in wound or the stator rotor, the stator itself will produce the magnetic fields. We don't have any brushes, or we don't need any brushes for AC machine, but we have what so-called slip rings, and we have slip rings to produce or to connect directly the DC source to the rotor one. But for DC machine, we need what so-called brushes or commutator to keep providing the same pole or the same terminals. Let's say we put a positive to the terminals, so we have to keep the positive terminals alternately, and so that we have we need brushes. So DC wound field motor are constructed with brushes and commutator, which add to the maintenance. So this is the issues with the DC machines. We have to maintain because the brush will deplete accordingly, and also the limit will speed. The speed of the limit will be affected by the placement of the brushes. And the speed control, the speed is controlled by varying the frequency, because we know that the frequency of your, or the speed of your AC motor or AC machine will be directly proportional to your frequency of the system. Meanwhile, the speed of the DC machine will be varied. We are able to vary the speed of your DC machine by varying the armature windings current. We adjust the current, we are able to adjust the speed. This one is only by adjusting the frequency of the system. So in terms of electric motor, we can divide by two categories, main categories, which is from AC and another one from DC. From AC, divide into synchronous, meaning that non-synchronous, and also synchronous. And we can divide into two main categories of synchronous, and segerak dan tidak segerak, synchronous. Meanwhile, synchronous we have learned on the single phase, which is need the starting method of either in kind of permanent split capacitor, capacitor start, capacitor run, shaded poles, split phase, variable reluctance we don't touch yet, or we neglect this one. And we have also polyphase, means that not only in three phase but maybe in polyphase, maybe a three phase and etc. 6 phase and synchronous. So the polyphase we have in kind of squirrel cage. Squirrel cage means that we just provide interconnecting bars to the rotor, and we have wound rotor, and means that we are able to control in terms of the resistance of our rotor connection. And we have synchronous receivers. This one you have not touched, no? And asynchronous we have AC brushes, which can construct into universal. This universal motor, which can be supplied by DC or AC. The construction of universal motor. So this one also we haven't touched so much. And we have synchronous, the synchronous kind of motor, which we will look into the machine later. We have a sine wave synchronous motor, wound rotor, PM, permanent magnet rotor motor, synchronous condenser, and then we have stepper motor, and means that the motor can be controlled in kind of step. Most of stepper motor used inside of printer lah. So we have multiple kind of frequency controllable. So we have variable reluctance, permanent magnet type, hybrid. We have brushless type, and we have reluctance, self reluctance or speed control reluctance, synchronous reluctance, switch reluctance, kind of synchronous machine. Then you can go through this link to see the difference of synchronous compared to induction machine. You can click this link and go to the YouTube link to further understand on the difference between these two kind of machines. Okay, we have a saline pole characteristic, and the other one is non-saline pole. You can see the difference. Saline pole means that the poles will be protruded to the gap, and meanwhile we have non-saline pole, the poles is embedded into the rotor. So that's the main difference between the saline and non-saline pole. Okay, saline pole generators. The magnetic poles are on the rotor can be of either saline or non-saline construction. Okay, the saline means that the protruding or sticking out. You can see the sticking out. So the magnetic poles that stick out radially from the shaft of the rotor. So we have lateral magnetic windings called the coils will be wrapped around the pole itself. You have to put, or you have to use 4 or more poles. You cannot use only 2 poles. So the minimum pole is 4. So maximum poles is limited by the construction of the machine itself. Okay, we go to the next slide.